Hi, in today's video I want to show you how you can apply the Realtime Patch to the Linux kernel. So today we will get the patch, apply it to a Linux kernel, configure it, compile it, and then run it on an embedded system. And for my embedded system I choose the phyBOARD session from phyTEC. If you want to learn more about this board, I will put a link to phyTEC in the description down below. Before we start, let's talk a little bit about the theory or what the Realtime Patch is. And I want to start with a common misunderstanding. So applying the Realtime Patch to a Linux kernel doesn't make the system running faster, or this is not the intended use of the Realtime Patch. What the patch does is it gives you a more deterministic behavior. What do I mean with this? Well, if you are running a real-time operating system, it's crucial that if you have an input event, you will get a reaction from your system in a given amount of time. And this amount of time can't vary much. Or, for example, if it takes longer, this is a no-go. This is very bad. So how does the Realtime Patch give you a more deterministic behavior? Well, first you will get an improved scheduler. So in Linux you have a scheduler which will assign time to each process or computing time to each process. And with the Realtime Patch you have more options or more abilities to assign priorities to each task. And with these priorities it's possible that a high priority task will interrupt a lower priority task. Another important thing is preemption. This means that critical sections can also be interrupted. An example here is if an interrupt occurs, normally the standard kernel would just call an interrupt service routine. With the Realtime Patch, the interrupt service routine won't do the handling. All it will do is it will start another thread, and what was in the interrupt service routine's code before will be handled within the thread. The thread has an assigned priority, and this means a higher priority task can interrupt the interrupt service routine because now it's just a thread. Okay, yeah, this was really just a very, very rough overview about some things the Realtime Patch does. If you want to learn more about the Realtime Patch and maybe see how to assign priorities, please let me know in the comments and maybe I will do more videos about this topic. But now, enough theory, let's get the patch and let's apply it. Okay, so let's go to my browser and let's get the patch. Here I am at the page. I will put a link to this page in the description, basically under kernel.org/pub/linux/kernel/projects/rt. You can find all the RT patch for the various kernel versions. And I want to go with kernel version 6.1. And in here I can see the most recent kernel version 6.1, which is 6.1.73. If I want to use an older version, I can go here in the older folder, and you can see I have multiple files here available. So first we have two different compressing algorithms used here. The sign file is just here to check that what we have downloaded is exactly what it should be. And here we have one time a patch and we have patches. So in the patch, all the various patches for the different files in the Linux kernel are in one big file. And in the patches download, we would, for each file which was patched for the Realtime Patch, we will get a separate patch file. So because it's easier, I will go with the single file solution and I will download it here. Okay, the next thing we need is we need to get the sources for kernel 6.1.73. But if I look at kernel.org, you can see the most recent kernel 6.1 kernel is more recent than what's in the patch folder. So I need to get an older kernel version. And how can I get this? Well, basically here at pub Linux kernel, I can browse all the kernels. I want to use a 6.x kernel. And then I have to search for 6.1.73. And here we go. Yeah, not the changelog, I want the kernel. Yeah, here it is, and now let's download the kernel. So let me go to my programming folder and I will call a new folder here I will call Realtime Linux. And in here I will move the downloaded patch. And with GNU unzip I can unzip it. And now I have a patch file here, and if I take a look at it, yeah, you can see it's just a patch basically. And here you can see, for example, here this line is added, or here this line is deleted and this line is added, and that's basically all the content here of the file. Okay, then let me extract my kernel. So it's 6.1.73. Okay, this will take a little time as the kernel is a little bit bigger. And then I will navigate into my kernels folder. And now I want to apply the patch. And this I can do with the patch command. So if you look here, we have, or the way the patch was created was by using the diff command, and we compared A arch arm kconfig with B arch arm kconfig. So A would be our original kernel and B would be our patched kernel here. The problem is I don't have an A and B folder here, so I need the option P1. This means the A is stripped from the patch, and then I will just pipe in the patch. And here I can see all the various files which are patched. So for example, here we see some files regarding the scheduler are patched, which is important because we will have an improved scheduler. But also a lot of other files are patched with the Realtime Patch. Okay, cool. So now we have patched the kernel. Now let's configure and build it. So from my QEMU tutorials, I already have a cross-compiler in hand which I can use, and I can find it here. So this is the cross-compiler I want to use. And for configuring the kernel, I have to specify the architecture I want to use. I will also specify the cross-compiler I want to use. And with help, let's see which configs are available. As I'm running an IMX board, I will use this configuration here. So instead of help, just typing in the configuration, and then our kernel will be configured. Okay, this is done. So now I can start the compiling process. Therefore, I will just call the makefile, and I want to use all my 12 threads here for my CPU, so the compilation is a little bit faster. So let's start this, and now the kernel will be compiled. So I will stop the video for now, as the kernel compilation will take 5 to 50 minutes. So yeah, I'm back when the kernel is compiled successfully. Okay, so our kernel is ready. So let's copy it. I've already prepared an SD card. Let me show it to you. Okay, give me a second. Having technical difficulties. Yes, now here it is. And here you can see we have an older kernel image which I will overwrite. So let me remove it right now. Okay. We have a root file system already compiled for this board, and we have our device tree. And what I will do is I will just grab this file here and copy it on my SD card. Okay, then let's unmount our SD card and let's plug it in our phyBOARD session and start up the system. So you can see here I have a serial terminal connected to it. So let me fire up screen. So we can see the kernel's log and we can see the system booting. So now I will connect the micro SD card to this board. Okay. And now let's apply power and start up the system. Wrong way. Yeah, now it's booting up. We can see the kernel gets loaded and the root file system was loaded, and now the kernel is booting. And in a few seconds we should be able to get a login prompt. Yeah, here we are. So we are running my minimal Linux system, and now if I apply uname -RA, we can see the kernel we are running, and we are seeing it 6.1.73-RT22. So it's a kernel with an applied realtime patch. Cool. So I guess that's it for today. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy me a coffee and buymeacoffee.com/Linux. So thank you for watching and goodbye.